Hello, everyone. Welcome to Talking Tech. This webinar is a collaboration between IEEE USA and CEWIT, the Center of Excellence in Wireless and Information Technology at Stony Brook University. My name is Rong Zhao. I'm the Center Director for CEWIT. It is my great pleasure to introduce the moderator for today's program, Mr. Ed Palacio. Ed Palacio is currently the IEEE USA president. As a business executive, he has over 40 years of experience in directing development and production of complex electronic systems. He has held profit and loss responsibility at the business unit and sector levels, as well as functional lead positions in program management, engineering, and operations. Currently, he is president of P&L Technical Management Solutions, a small business focused on technology, program management, and business development for the military and civilian market. He is and has been a member of multiple advisory boards in industry, academia, and professional organizations. Ed holds a BEE degree from the Cooper Union School of Engineering and Science and 2 MS degrees in electrical engineering and technology management from the Polytechnic Institute of New York. Ed, please take it away.
Oh, thank you very much, Dr. Zhao. As he stated, this is our webinar on advancing climate solutions through innovation. And we are very fortunate to have a panel of distinguished professionals who are quite knowledgeable in this field. So let me begin by introducing our panel. First is Robert Catell. Mr. Catell was formerly chairman and chief executive officer of Keyspan Corporation and Keyspan Energy Delivery, the former Brooklyn Union. His career with Brooklyn Union started in 1958. He became chairman of National Grid US, and then following the acquisition by National Grid, chairman of Keyspan Corporation. He currently serves as chairman of the board of the Advanced Energy Research and Technology Center here at Stony Brook, as well as the National Offshore Wind Research and Development Consortium. Mr. Catell is a past chairman of the American Gas Association, Brooklyn Chamber of Commerce, Futures in Education Endowment Fund, Kaira Energy Management Limited, Long Island Association, the New York State Smart Grid Consortium, Partnership for New York City, U.S. Energy Association, and the Advisory Board of the City College of New York School of Engineering. He received his bachelor and master's degree in mechanical engineering from CCNY and is a registered professional. And welcome, Bob. Thank you for being here.
Thank you. Thank you, Ed, for that very nice introduction.
Now, the next I want to introduce is Dr. Kevin Reed. Dr. Reed is the interim director of academic research and commercialization programs at the New York Climate Exchange, a new nonprofit focused on the open exchange and collaboration that empowers sustainable solutions to climate change for New York City and the world. Dr. Reed leads the strategic direction and facilitates the co-development of academic, research, and community programs with a diverse set of academic, industry, and community partners. Dr. Reed is also the Associate Dean for Research and a professor at School of Marine and Atmospheric Sciences at Stony Brook University, where he founded and leads the Climate Extremes Modeling Group, which focuses on investigating how socially relevant extreme events, such as hurricanes, may change in the coming decades. Dr. Reed received his PhD and master's in atmospheric science from the University of Michigan, where he also completed a graduate certificate in science, technology, and public policy, as well as BS in physics. And Kevin, thank you for being here.
Yeah, thank you for having me.
Now I would like to introduce Digaunto Chatterjee. He is the Vice President in System Planning at Eversource, the largest utility in New England, with responsibility for transmission and distribution planning for the 3 public utilities across Massachusetts, Connecticut, and New Hampshire, as well as the integration of offshore wind in New York and New England. Mr. Chatterjee oversees and guides the technical studies that serve as the foundation for developing the 10 and 20-year transmission and distribution reliability and resilience capital plan. Eversource's strategic technical studies incorporate scenario-based probabilistic forecasts that include impacts of transmission and distribution-related renewable generation, electrification, and more recently, climate change. Mr. Chatterjee began his professional career over 20 years ago at GE Energy Consulting. He subsequently worked for MISO, where he led reliability and economic transmission planning, as well as resource adequacy. He then served as Vice President Investment Strategy at GE Capital, where he led the energy and capacity market analysis to inform renewable energy investments decisions. Mr. Chatterjee earned his bachelor in power electronic engineering from Nagpur University in India. He earned his master's in electrical power engineering from Rensselaer Polytechnic Institute and an MBA from the University of Chicago Booth School of Engineering. Digaunto, thank you very much for being here.
Thank you for having me.
Okay, so let us begin this discussion addressing the urgency of addressing climate change. And in that light, what are some of the challenges and opportunities for making renewable energy technology a global public good? And Bob, could you take this on as
Sure. Thank you. I'll be happy to kick it off. It's a pleasure for me to be here and to be part of the panel with my esteemed colleagues. As Ed indicated in my intro, I'm a graduate engineer, City College, and being an engineer, we learn in engineering school that you want to solve problems. So I've spent my entire life trying to solve problems. I had the good fortune of spending my entire professional career in the energy utility business and transitioned when I retired, if you want to call it that, out at Stony Brook University and chair the Energy Research Center. The Energy Research Center in its foundation was, as its mission, was to develop new technologies to integrate clean energy into the mix. And what I try to do is bring my practical experience in connection with the brilliant professors to try to find the solutions. As I look at it, the challenge as we move to a lower carbon energy mix is how do we incorporate renewables into the system and maintain both the reliability and the affordability of the electric system, which we've been very fortunate to have a very excellent performing energy delivery system in this country. And when I say we move to, I call it a lower carbon future, I don't necessarily go to zero carbon because I think getting to zero carbon may be not capable certainly in the short term, maybe in the longer term. And the major things that we're looking at to reduce carbon, which we should do, is to incorporate renewables into the mix. The major renewables that we're looking at are solar and wind. There's other things we could talk about, but those are the two major things that people are talking about integrating into the grid. So the challenge is, how do you manage those two resources, which are not necessarily as reliable? The sun doesn't shine all the time, the wind doesn't blow, yet the electricity must keep flowing at all times. And how do you integrate that into the system? Having said that, the solutions, in my opinion, are going to be on the new technologies that we can develop, starting with battery storage, coming up with real utility scale storage, which is economic, affordable, and reliable, looking at things like hydrogen. So I think the challenges are there. The solutions, in my opinion, will be to develop the new technologies through energy research, which I'm involved in, which will be able to solve those technical problems, which I think are solvable, but I think it's going to take us some time to really find the solutions.
Thank you, Bob. Dr. Reed, would you like to add or comment on that?
Yeah, I mean, I think just to add really quick, which is that, a big part of helping to accelerate these solutions for New York and beyond is really thinking about the talent part, right? So going back to the way Bob started his response was talking about as an engineer, right? He really wanted to focus on doing things. And I think that it's important if we want to really accelerate solutions in this space for the urgency of climate change, that a big part of it, right? I'm an educator first, and a big part of that is engaging our students, the talent that are going to not only help implement some of the solutions that we've already developed, but they're going to be the ones that are coming up with the new creative ideas, right, that are going to unlock that potential in the future.
Thank you. And Digaunto, do you have a...
No, I think Bob and Kevin encapsulated it almost comprehensively. In New England, in addition to wind and solar, we're also looking at bringing in hydro imports from Canada. And if there's one common theme in all of that is offshore wind in both New York and New England are distant from our load centers, and solar is typically is built in areas which are remotely populated, and Canadian hydro is quite distant. So for us as the grid operator and owner operator, our main focus is how we integrate all of this, and how do we integrate this in the most efficient way. You had mentioned for the public good. We think of generation interconnection today as an interconnection problem, and we solve that as an interconnection problem. But when you step back and try to assess why are these clean energy resources really trying to connect, at the end of the day, they're driven by state policy goals that are trying to reduce greenhouse gas emissions. So when you think of it at that level, you start to think about, is the interconnection planning process really the right approach, or should we have a more holistic way we can plan the grid to accommodate these future resources in a timely manner?
Thank you. And that leads us very nicely. I think my next question is, look, how can countries and communities accelerate the transition to renewable energy resources? And Dr. Reed, I'd like you to start that.
Yeah, absolutely. And I'd like to start it from just a little bit of the context of, as you mentioned in my bio, that I'm recently named the interim director for programming at the New York Climate Exchange, which is a brand new nonprofit focused in New York City on helping to accelerate solutions in this space for New York City first, but thinking about how that ecosystem that you build in New York City can help translate internationally and globally to different types of communities. And a big part of how we've I think the framework that we've proposed and are looking to implement now is really focused around the co-development or in the co-design of new ideas and solutions directly with communities and different types of community partners. So communities can, of course, be physical, right? They can be tied to a location, but then there's, of course, the communities that are related to a specific sector or industry or lived experience of some sort, right? And so when we say communities, we kind of think about it in both of those contexts. But in the best way to have the rapid, adaptation of some type of new technology, whether it be, the use of offshore wind or, community scale solar, for example, or the hydropower that was just mentioned, a lot of it is first having the communities feel like they actually have a say, right, in the transition that's happening. And so part of that, of course, is through outreach and informing communities about what are the opportunities and why is renewable and clean energy so valuable, both at the community level as well as the globe level, right? Because we're all part of that system. But the other aspect is that when we think about what is the new technology or what is the new type of systems that could be deployed in the future, I think it's really important that we develop those ideas in mind with those communities in mind, and that sometimes they're developed right with the communities. And so if you're testing a new technology to let's say, help integrate renewables into a specific region a little bit more, smoothly, then the idea is you've got to engage that community early on in the process. And so that's one of the aspects from the New York Climate Exchange perspective. But another aspect that I just want to hit on that, of course, it matches well with stuff that's done here in the R&D park at Stony Brook, but also with the partners at New York Climate Exchange, which is thinking about how do you really start to foster that ecosystem so that the model for innovation that's done here around areas of clean energy can be translated to other parts of the world. And a big part of that is providing space for rapid prototyping of new technologies, right? And that's a big part of what we do at Stony Brook, but of course what we want to do at the New York Climate Exchange. And another aspect that then, once you have that rapid prototyping, is thinking about how do you incubate and scale up new solutions. And of course, access to ecosystems of seed capital is a very important part. And that, it's easy as a New Yorker to envision why that's easy to do in New York City, but it's less easy to think about that ecosystem in other parts of the world. And so creating ecosystems that can kind of build off that is, I think, critical to scaling these up and building these type of new technologies throughout the world. And then the other part kind of comes back, which what we were talking about on the last initial question, which is, access to talent. There's talent all over the world. There's new ideas all over the world and in different communities, both in here in New York City and Long Island, as well as elsewhere. And it's how do you tap into that? How do you get students and communities and residents, right, invested or wanting to be part of the solution and help to come up with those ideas and be that doer kind of that Bob had mentioned that started his career. And I really think that kind of fostering, that type of involvement in the community, that's where it kind of comes back full circle to that initial point, right? That if the community is both involved in the projects, but also involved in new ideas, and you actually come up with the new inventors of the future. And then I think the one other part that I just want to stay, it's probably pretty obvious, but another aspect for helping to scale and how communities can kind of think about employing these accelerating the transition. In a lot of cases, it's through outreach, because a lot of places where we're really limited is by policy, right? So in New York State and New York City, the policy is very favorable for the quick transition to renewable energy and clean energy sources, but that's not true everywhere. And so policy, of course, is one limitation that we have to think about. But it's also true that there's all the other stuff that comes with an energy transition, right? You're talking about building code, you're talking about, right, restrictions on the grid and all other types of policies that are very complex. And so I think it's continually thinking that we need to, evaluate the policy landscape and how do we model that so that other communities and places around the globe can help accelerate by not having to be hamstrung by policy.
Thank you. Digaunto, I know you want to add to this, so please let me listen to your view.
I would just add, no, Kevin perfectly encapsulated how we think about community engagement. Our communities want to be engaged faster, earlier on in the process, and more often.
Yep.
And in our latest filing that we made with the Commonwealth of Massachusetts, we submitted our electric sector modernization plan. It's a significant infrastructure plan, as you can imagine, with 150% increase in electric demand. And one of the critical things that we have done in that, for the first time, in addition to establishing a clean energy stakeholder advisory group, we call it CSAG, is a forum where all the community leaders can actively engage with the utilities as we're developing those solutions. But also secondarily, but not secondarily, but not any less important, is that we have, for the first time, translated our electrification infrastructure plans into household level electrification hosting capacity that is generated by this infrastructure. And the idea there is really informing the policymakers to direct their incentives for clean energy into those those communities that host this infrastructure. So there is, for the first time, a direct linkage between the state or the Commonwealth's clean energy incentives and the utilities plans going directly into those communities that are hosting this infrastructure, so they directly benefit from adoption of new clean energy resources, from heat pumps to solar to battery storage to electric vehicle infrastructure. That's something I'm really proud of, and hopefully that serves as a template for going forward in other utilities as well.
Thank you. Very important and very good. Bob, I'm sure you have something to say here.
Well, there's not a lot I can add to what Kevin and Digaunto has already said, but two things. And I think education and involvement is critical at all levels. Starts with the policymakers right down to the community. I think that's key in getting these things accomplished. And I can say this, Digaunto, because I'm no longer in the utility industry. I think the utilities can play a critical role. They have to play a critical role. And the regulatory environment has to be receptive. Digaunto mentioned they made a filing with their commission. Utilities can only spend money if their commission allows them to spend money. So we have to educate the policymakers and the commissions about the critical role that the utility, in my opinion, has to play in this transition. The utilities that I know of, Eversource is a great example, are really committed to make this transition to clean energy, but they have to have the ability to do it. And that goes through their ability to invest their capital in the new technologies and the transitions that's going to be necessary. So I think that's another point that people need to realize, that the utilities must play a critical role in this transition.
Thank you. So now I want to go into a point that I think all of you have touched on, and that's the grid itself. How can we build a more resilient grid that can withstand the challenges of climate change? And Digaunto, I want to start with you.
Yeah, so by doing a lot of analysis and with a lot of data, just stepping back even 5 years ago, what a system planning or a grid planning department in a utility looks like today is monumentally, seismically different than what it looked like even 5 years ago. And so how we think about climate mitigation plan and climate adaptation plan, of course, there is a lot of interconnection issues tied to rapid adoption of clean energy, or distribution infrastructure plan for rapid adoption of electrification. All of that is necessary. But I think climate change is something that we just have to learn how to adapt to. And by we, I mean everyone, not just the electric grid, but everyone associated with living in some of the vulnerable areas. So how we think about climate vulnerability, at least on the electric sector, while there are many other sectors within our sector, we think of high temperature, we think of flooding risks, both coastal flooding as well as inland flooding. We think of storm surges. We think of heavy precipitation, but most importantly, the fluctuations between drought and heavy winds, the intensity and frequency of storms. If we think back of 40 years of storm data in New England shows Sandy, Irene, Isaias, Alfred, these are 1 in 30, 1 in 50-year storms. And if we compress that period of looking back at storms to just 15, 20 years, those return periods of those same storms start to look like 1 in 15, 1 in 20-year storms. So think about that. Not even looking at the IPCC reports of future climate change, just looking at past storms, the return period of each of those storms has dramatically increased. And then when we look at the number of outages we see on our system that these storms cause, they are now causing on average 2 to 4 times the number of outages. So they're coming at us with higher frequency and they're coming at us with higher intensity. So that set aside, the other risk in New England, and Bob touched on this, wind doesn't blow when all the time, or sun doesn't shine all the time. What that translates to for us is probabilistic modeling. We have a well-established since 1940s loss of load expectation study framework that's used in capacity markets today to procure resources that we need. That same construct today is divorced from transmission planning. So there's resource adequacy in a separate world, and transmission planning looking at reliability needs, but there's no connection between those two. So addressing climate change from high wind speeds, high temperature, that can be done in your all-in SAIDI, all-in SAFE metrics. Utilities, again, have to create metrics, have to work off of those metrics so they can quantitatively then translate those impacts into specific circuits on our system so we can deploy capital on specific circuits. And then when we think about where to deploy, we have to think about how to harden it. Do we underground everything? Of course not. If we do that, that's a massive price on our distribution customers. So we have to get more tactical. What kind of design is there today? What can we do with overhead structures? Can we make overhead structures more resilient? Can we sectionalize circuits? Can we add more circuit ties? Can we add more redundancy on the system before we exhaust all of that and identify specific communities that are going to be just pummeled with these massive storms? And in those areas, it just does make sense to just underground it. But on the energy security, on loss of load expectation, resource adequacy, every winter, as you know, in New England, we come very close to running out of natural gas and running out of oil with LNG tanks in New England. This is a major issue for us. And as we retire some of the fossil fuel power plants, those oil and natural gas generators, and lean more heavily on offshore wind and solar, I think it doesn't take too much science to determine that we need more ties. New England and New York both need more ties between each other's systems so we can all decarbonize collectively without actually negatively impacting reliability. So that's where our focus is, on the energy resilience side as well as from the storm resilience side.
Thank you. And so from your view, it's a very holistic issue that deals not only with matching, the characteristic of the technical aspect, but also maintaining a grid and then dealing with the fact that the energy can come from multiple places and you have to be able to transfer it. So thank you very much. Bob, I want you to follow up on that, if you can.
Well, there's not a lot more I can say. I think Digaunto covered it really well, and many of the different aspects. I think the only thing I'd like to maybe build on, and it goes into, I know the questions that we're going to talk a little bit more, is as the utility is doing its planning, it needs to take into consideration the new technologies that are being developed. And I know they're doing that, but that's going to be an important part of the solution. But I would also like to reinforce what Digaunto said at the end about the connectivity. We need to have interconnectivity on the gas and the electric side. We're talking about electrifying a lot more than we did in the past. So that's going to require the need for more electricity, but a lot of that electricity will still be generated by natural gas for some period of time. So you need to have the adequacy of supplies. So we're going to have to build some more infrastructure. And building infrastructure is never easy. Nobody wants it in their backyard. That's part of the education. That's part of the involvement that we got to do. But I think the real solution here, in addition to the reinforcement of the grid, is the interconnectivity, and then, of course, the new technologies, integrating them into the grid. It's a very, very different utility business, Digaunto, than the one I grew up in.
Very good. And Kevin, I know you want to add here.
Yeah, let me just add something around the idea of, how do we better stress test the grid for these changing events, right? Particularly in the extreme. So, right, as we talked a little bit about already, if you're planning your grid around the 1 in a 50-year storm, from 50 years ago, then you're planning against the wrong storm, right? And so the idea is that, of course, those storms are becoming more frequent, as we discussed with the Hurricane Sandy as an example. But there's also new types of extremes or duration of those extremes, right, that we don't maybe have an example of in the past to plan for. And so, I think the ways, and thinking about how to make, right, the grid more resilient, it is, I think, also stress testing in the context of climate change, even more so than just saying, okay, this is a once in a 20-year storm now, but what is that other storm out there that could exist, right, that we haven't planned for? Or what is the worst case heat wave, right? Is it multiple days over a certain temperature, which would really stress the grid? And it's important then to think about that and how do those extreme events co-locate with the use of the renewable resource, right? So you can imagine that oftentimes when we have our hottest days, it's not a very windy day, right? And so you can imagine that there's already implications of your energy demand might be high when you don't have the certain types of renewable. And so that's what I think I mean by stress testing in the context of climate change as well. It's not just how are the extremes changing, but how might they co-locate with the type of energy that your grid will be pulling from. And I think there's great examples of folks already doing that, but I do think that, it does kind of change the game a little bit to the way we would have designed a grid, both 50 years ago in a world with less climate change, but also 50 years ago within a less of the diversity and clean energy that we have now.
Yeah, and I think as you state, when you look at all the scenarios, different scenarios will push you to different design points, and you have to take into account all the different design points and design the appropriate system, which, by the way, brings us to a discussion in technologies. And so so now I'm going to ask, what are some of the innovative technologies and solutions that can help reduce greenhouse and gas emissions and enhance renewable energy production? And Bob, I'm going to start with you.
Okay, well, I think, we've touched on a lot of it, but to try to be a little more specific, and it's kind of the world that I'm living in right now at the Energy Center, the Offshore Wind Center. And I think, and I didn't say this before, but I think one of the things that's important is that we maintain the ability to continue to do research. We've got to be able to have the funding available to do research, because that's where these innovative technologies are going to come from. Some examples that I like to give, and Digaunto talked about, delivering the electricity to the load centers. There's a lot of work being done in the area of superconductivity. Now, what does that mean? Most transmission lines today are a certain voltage and a certain size. We're going to have to be able to find ways to deliver the electricity to the load centers in a more efficient manner. Digaunto touched on that. Research is being done in superconductivity on the transmission side. There's a lot of work being done in the area of what I call distributed generation. The old utility system had large generating plants, and the juice went out radially. Now we're looking at being local distributed, community solar, and things of that nature, which are and that presents a lot of challenges to the grid, but it presents a lot of solutions. It gets us away from the large generating plants that we built over the years. And one of the things that a lot of focus is being given on right now is hydrogen. As you probably know, hydrogen burns. Basically, it's H2, it's water and hydrogen, so it burns very cleanly. But there are a number of challenges, but there are a lot of opportunities in making hydrogen, in decarbonizing the grid by making hydrogen part of the mix. And a lot of work is being done on how much hydrogen can you incorporate in the natural gas stream? Can you go to 100% hydrogen? What about hydrogen going into combined cycle electric generating plants? And last, certainly but not least, is in the battery space. There's a lot of research going on in batteries. We all have batteries in our phones that work very well, but we don't have large batteries right now at a utility scale that can maintain the grid when the wind's not blowing or the sun is not shining. So there's a lot of research going on in that space. I'm optimistic about it. And last, but certainly not least, is how do you integrate all of this into the electric distribution system? So there's a lot of interesting work going on in modeling the system, determining how to integrate these grids. The computer will play a much larger role. And as I look at this, we talk about challenges, but if I was a young person, again, looking at the energy industry, I'd see a lot of opportunities in that space.
Thank you. And Dr. Reed, I want to hear your view.
Yeah, so I mean, I think well, first, just that Bob gave a good list of a lot of, I think, the great opportunities. I mean, I think maybe I just want to add really quickly to the last point around computers, and in the sense that I'm a computer modeler with my science hat on all the time, and I in that context, I think computers are going to play a large role, right, in building smarter systems to not only manage the demand, but also understand, how the demand might be changing in a few days. But I think the other side of where there can be huge benefit around computers is really the integration with other systems, right? And so the sense is that as our weather forecasts, for example, have improved significantly over the last 30 years, right? How do you better not only integrate that information, but that information is coming at higher and higher spatial resolutions, at higher and higher temporal resolutions, right? And so at what frequency should you be integrating it? How is it different than you would have integrated it from 10 years ago? And I think while it's a huge opportunity from a technological standpoint, I think there are some exciting challenges. So I'm a scientist, so I'm excited by challenges, right? Because I mean, there is that opportunity to investigate. And I think there's a lot of opportunities around those challenges of thinking about how to best integrate smartly and much more efficiently.
Thank you. I am curious, though. No one spoke about nuclear. So anyway, Digaunto, I want you to kind of follow up on this discussion.
Let me see if I can tie what Dr. Reed and Bob mentioned. Our SSP2 4.5 and 8.5 scenarios that we're seeing for climate change, on average, we see about 2 to 3 heat waves every year. That's projected to grow from 2 to 3 to 5 to 7. And on average, a heat wave that we see on the system today lasts roughly about 4 to 5 days a week at best. We are seeing some of those rise to 20 to 25 days. So if you think about these large rotating machines that we built since the 1970s, 60s, they provide a significant benefit to the system in terms of rotating mass inertia on the system for grid stability. And if we just retire all of it, right, it just seems like we would have a sort of a wasted opportunity, right? If all the objective is to reduce greenhouse gas emissions, but retain reliability. Another technology that Bob mentioned is really effective. If we have either on-site generation of hydrogen co-located next to those power plants, or a generation of hydrogen close to that area, supplying hydrogen through direct pipes into some of these large combined cycle power plants, either initially as a blended opportunity, and with a transition, both I believe both Siemens and GE are well on track to get to. They've already test fired 30% blend, and eventually getting to 100% blend. So I think it's incumbent on the transmission owners thinking of where the right spots are for locating these electrolyzers, as well as distance-wise from the gas utilities, how to build the piping infrastructure to supply hydrogen into those areas. But just thinking about that climate vulnerability of those extended periods of really high temperatures for really long number of days, we have to think about utilizing hydrogen in that mix very effectively to provide reliability.
Okay, so I did ask the question. So why have we not spoken about nuclear at all, Bob?
I think it's, so let me step back. I mean, you all know this, but New England used to have 48% of all generation used to come from nuclear. Sure. And policies have, for good or bad, I think hindsight is 20/20, but I think if we all look back and see, hey, would we have been better off with Vermont Yankee power plant, or Yankee, or Maine Yankee, all of these power plants that New England retired because of various policy initiatives? I think we would all say, no, I think we would have been better off with nuclear power plants still around. I think the safety of nuclear power plants has without question no demonstrated risks in New England. I think it's a really good tool in the toolkit. Having said that, the cost of rebuilding that Vermont Yankee today is insurmountable, right? So yes, are there SMRs? Are there small reactors we could have more geographically distributed? I think if you hear from me as a system planner ever that there's only like a set of solutions that are under considerations and not other set of I would not be a good system planner, right? So it's always all of the above.
Bob.
Well, I just to add to that, and when people ask me about, solving our energy and environment problems, my comment is there's no single silver bullet solution. There are many. You have to look at all of these options. I think, as Digaunto mentioned, the smaller nuclear reactors will play a role in the future. Some of the challenges we had here in the Northeast is where the nuclear plants were located, the size. Maybe again, in hindsight, we might have put them in other places. But I think nuclear long-term is going to be part of the solution.
Thank you. And Dr. Reed, anything?
Yeah, I don't have anything to add. And just to reiterate the point that's been said twice now, which is that, right, the only way I think we'll solve our energy kind of I'm a climate scientist, so we're in a climate crisis, right? So in order to solve this and reduce our greenhouse gas emissions, we need to use every technology and every source that's out there that doesn't produce greenhouse gas emissions. And so the analogy I heard a long time ago, just to really add to this, right, is that if you want to drive somewhere right now, of course, this is changing big time. But 10 years ago, you had to go to a gas station, or if you wanted to power your home, you kind of were typically were coming from a coal power plant. But at that same gas station, if you walk in and you're thirsty, right? There is 100 different types of drinks in that gas station. And then now if you like soda, let's say you just want soda. So okay, I want soda. There's at least 30 different types of soda available to you. And so, right, it's interesting right? So that tells us that if you need, whether it's caffeine or you need to be hydrated, that you have all of these different options. And what we need is that the gas station and the energy sector to become the refrigerated part of the gas station, right? In which we just need a bunch of options, and each option will be different, right, for each region of what their selection is. But I think that that's the key.
Thank you. I think that was great. Okay, so I'm going to go into now slightly different, and I think Dr. Reed, this is kind of on your bailiwick, right? Climate monitoring and prediction. How are climate models built? What technologies, in other words, like satellite imaging, can help scientists better understand climate change and track its effect? So I'm going to start with you, Dr. Reed.
Yeah, well, I'll try to keep it quick, because as a climate scientist who uses climate models and has been involved in developing new climate models over part of my career, I could probably talk all day about this. But first, let's step back and say, well, right, what is a climate model? I think we typically see this brought up in the news of a climate model. Scientists project using climate models that the world is going to be, XYZ, or as we just talked about, heat waves, right, changing. So what is a climate model? A climate model is, I think, an amazing demonstration of technological advances, both on the software and the hardware side of things globally. And it really shows what international cooperation can do, right? And so a large part of what new climate models are, they are numerical approximations to try to represent the climate system. And it's done mostly in two ways. The first is by solving the different types of equations of motion or conservation equations on a sphere. And so the atmosphere, for example, big component of a climate system, is just a fluid, right? And so we solve those equations of motion, but we're limited by what the resolution of those models can be based upon our computers. And so there's large parts of that climate model that then have to be approximated, or what we call parameterizations. And so you could imagine, right, a good example of this is wind flow on the scale of what our weather is going to be like day to day is well resolved dynamically with the equations of motion, but the individual clouds and where the rain happens is so small scale, right? Sometimes a cloud is smaller than a kilometer, where the grid size of the model might be 100 kilometers, that you need to parameterize them. But we do that where those parameterizations are based in theory, and they're based in diverse sets of observations over time. And that's just one component of the climate system that's included in climate models. That's the atmosphere, right? We have the ocean, we have the land surface, we have the ice caps, we have land ice, we have the carbon cycle, which is built into all of those. And so these models become inherently complex. And so oftentimes I think for some models now, it's on the order of 2 million plus lines of code, right? So these are not only complex, but they are some of the largest code bases developed anywhere on Earth right now. And this is done now, and it's not just one, right? We have dozens that are developed by different countries. The United States has a variety of different laboratories that have their own climate models that they've developed. And the other side of it is that these models have been able to get so complex over time and include all of those processes that we know are important for representing the Earth system, because they've been able to really sit on all of the technological advances that have happened in building faster and more efficient computers. And so not only are they the largest code bases, but they're typically run on the largest and most efficient supercomputers in the world. And a good example from my experience is the Department of Energy, the US Department of Energy actually, right, has some of the largest supercomputers in the world. And a big use of those supercomputers is actually running of climate models. So let's talk really quick about some of the other technological advances that have helped improve the accuracy of these models over time. And a big part of that has come from satellite measurements. So most of our in situ data comes from individual weather, locations or Doppler radar, and these type of things can be used, but they don't have homogeneous coverage over the world. Of course, parts like the United States have a lot more diverse data sets than other parts of the world. And And so a big game changer was the use of satellites to not only just look at weather conditions, but we can do anything from soil types, right? We can look at evaporation over the ocean. We can look at how sea ice is changing. And so these models help us, or these, satellites help us advance our understanding of the climate system so we can better build parameterizations that are used in the climate models, but they also allow us to stress test our model because we've developed now over 40 plus years of satellite homogeneous satellite observations has allowed us to verify and build better models as well. And so satellites have been a huge advantage, and there's continually new sets of satellites with higher resolution of data of the variable they're collecting, which only allows us to improve our models even more. In addition, they're becoming over now that we've had decades and decades of continuous satellites for things like clouds, for example, which are notoriously hard to monitor homogeneously, that now we're starting to develop a climate record, which better helps us develop our models. And then, so that's the big picture, right? So I said I could go on for another 3 hours, but I'm going to wrap up here and just talk really quick about where I think some of the opportunities for advances coming in the next few let's say next 5 to 10 years, which I think maps onto some of the discussion we're already having, for example, around grid reliability and integrating renewables, is I think climate models are going to be really critical for understanding regional climate. And that's something they're challenged with because of their resolution, but I think they're becoming a lot more nimble. Meaning here at Stony Brook, we run climate models that only have high resolution, like down to 20 kilometers, which is still relatively coarse, but that is the scale of operational weather forecasts. And so we can run climate simulations at operational weather forecast scales for whole regions like the Northeast. And that's some of the work that folks that I work with here at Stony Brook do. But you can imagine that could be used for a lot of different grids or the integration of renewables. And so I think the nimbleness of them is an important aspect. I think artificial intelligence and machine learning is a huge opportunity to take out a lot of the complicated, really expensive parts of the model. And if we have them are rooted in really good observations and good theory, that we can hopefully replicate a lot of that need in the model much more effectively and efficiently. And so I think artificial intelligence is a huge important part of it. And then the other aspect I think around climate models that are really going to be helpful for us is I think if we were to let's jump 20 years in the future and we're having another discussion like this, I think that what they could be used for is showing us what climate change did we avoid by doing all of that hard work in the 2020s and 2030s to reduce our greenhouse gas emissions. Because I think we're forward thinking a lot with climate models, which is important because they're to help us make decisions. But I think one important aspect is to be able to look back at some point and say, if we hadn't done that scale up of renewables, right, how much different would our climate be now? Because that to me is going to be really beneficial for the next time we have to have a quick energy transition or a quick transition of any sort, that we be a little bit more retrospective sometimes and say, look at the climate change that we avoided by getting our act together. So,
thank you. And Digaunto, I think I want to go to you because you also mentioned models, but you mentioned it in a slightly different context, but I am sure you integrate to this.
Yeah, no, it'll become apparent how utilities, it's a symbiotic relationship with universities, but I believe we're the only utility in the nation that has been able to successfully do this. We have taken the past 40 years of storm data, working with the Eversource Energy Center, built machine learning algorithms that predict what the wind speeds would be, and built fragility curves of individual classes of poles, and look at what wind speeds would impact how many clusters of poles. And the cross arms, the size of the cross arms and the wind speeds and the impact associated with existing bare wire, and translating that conversion of that cross arm from a 6-foot or 10-foot fiberglass cross arm to an aerial cable. What is the delta reduction in trouble spots? What is the delta reduction in trouble spots to go from a class 3 or 4 pole to a class 1 pole to an undergrounding pole, specifically looking at disturbances probabilistically of impacts of the 40 years of storms. We have then translated that to a restoration curve, because as you know, resiliency is not just about hardening, but the aggregate totality of the total restoration curve. We've then looked at, if you can picture a restoration curve that generally looks like an exponential curve, as you are bringing more crews in, you're reducing your trouble spots. We've been able to then recreate a future restoration curve based on 5 different levels of storms that we have, depending on the number of trouble spots, and then looking at the area between those curves to look at the storm material and labor costs saved from different scenarios of hardening plans. Again, this is based on probabilistic look at fragility curves of existing assets based on past storm. Where we are going is taking the atmospheric science data of humidity and temperature and pressure to look at recreating storm paths on the system so that we can now take that out to the next 10, next 20 years, because resilience investments, Bob mentioned this, we have to get regulatory approval for this, and quantification of that benefit of over the life of the asset, which typically these new hardening upgrades last 30, 40 years. How do we quantify that benefit? Not just looking back at storms, but looking forward in storms is really important for us. So we've been doing a lot of work on that.
Thank you so much. And Bob?
Not really a lot I can add to that, but having the ability to better predict, I guess, what the climate's going to be, puts the utility in a much better position to design the system. That's really, at the end of the day, the utility has to pick a spot. You know, Digaunto mentioned the heat wave that lasts for 10, 20 days. They have to have the capacity to supply. So they got to make a decision on what are they going to design for and what capability are they going to need. But the climate models gives us a lot more information to do that a lot more effectively and hopefully a lot more efficiently. And at the end of the day, less expensive to the consumer. So that's where the benefit of these climate models really come into play, in my opinion.
Well, that leads us very nicely, I think, to the next question, and that is, how are utilities planning to enable clean energy, and how are their climate adaptation plans evolving? And Digaunto, I'd like to start with you.
Yeah, you know, Kevin used the analogy of a gas station, so I'm going to use the analogy of Indian restaurant. You know, if you go inside an Indian restaurant, if you order chicken tikka masala, for instance, there is not one restaurant where they, after the order is taken, they go and kill a chicken and start the process, right? They've probably already got the gravy already made. They've already marinated the chicken. And they're simply cooking it, and you get your chicken tikka masala within 10 minutes of ordering it, right? Our sector doesn't work like this. It's bizarre, right? We have a new FERC order now that says not only do you need to plan for that one customer coming in through the door, now you have to estimate how many customers are you going to get this evening, and maybe you get 50 customers this evening, so you have to cut and I don't know how many chickens that translates to. That's how many chickens you'll have to kill that evening. That's not how the real world works either, right? Clustering generators into an interconnection process is not going to solve the problem. You're still going to wait for 3 hours before you get your chicken tikka masala on your plate. So how we need to think about it is project out a trajectory of where are we going to expect offshore wind to come in. And we did this in Eversource. If you think about New England coast, there are like 5. There are 5 existing landing sites where offshore wind can come in. That's it, right? So the natural then question is, well, can you create new landing sites? Yes, you can. But what's the incentive for the utility to do that, to build out the grid, and create new landing sites for offshore wind, plan the grid so that offshore wind can just connect, plug and play? That's where we need to get to at some point, where after the policymakers and utilities get together in the old school in one room, sit down on one table with all of the stakeholders, how much are we going to get to what of? MISO did this very effectively. Texas ERCOT did this very effectively with CREZ projects. MISO did it with MVP projects. That's what we need to do. New Jersey, New York, New England, all together. How much wind are we going to connect where and by when? That's on the offshore wind side. Same goes for onshore wind. Same goes for solar. Same goes for Canadian hydro that we all need. And then let it rip. Let the models drive our decision making on what grid infrastructure needs are there. And then once we do that, let's think about a new way of cost allocation so that you're not imposing all of those costs on a particular sector of generation that will frankly not be able to uplift all those costs. And once you figure out that bottleneck, then you figure out how to get all of this sited and permitted by making sure that the siting agencies of the various states are planned, are staffed up. Because if they don't have staff, just Ford Motor Company figured this thing out in 1950s, right? I think we can figure out, run out a process from beginning to end, figure out where the bottlenecks are, and then try to tackle those bottlenecks by either staffing or cost allocation or siting or just procurement and construction. Wherever the bottlenecks are, solve those bottlenecks, because if you don't, clean energy enablement is just going to be a talking point for policymakers. We're not going to get anything built. So that's where we are on enabling clean energy, building out the grid and positioning it so that we can enable clean energy proactively. And on climate adaptation plans, we submitted a $450 million plan. It sounds like a lot, but it's a step in the right direction, and it's only the first step. We proposed anywhere from $1 billion to a $6 billion plan in Connecticut to tactically underground and harden our distribution system in Connecticut. But Bob mentioned this, utilities have the capabilities to know what they need to do on their system with the help of universities and research centers and working with clean energy partners. It all comes down to the appetite of policymakers on how much appetite do they have to move some of this infrastructure forward in a constructive regulatory environment.
Thank you. So we have chicken, we had some soda. Bob, you get to finish the meeting. Go ahead.
Well, maybe I'll be a meat and potatoes guy, make it really simple. But I want to build on what Digaunto has said, and he laid it out very quickly. And the one I want to kind of interject into the discussion, you touched on it, Digaunto, is collaboration. I think we need to get people together in a room, so to speak. That's the meat and potatoes that I'm talking about. We need to be talking to each other. We have these very, very aggressive goals that we want to achieve. The players like the utilities are committed to try to meet those goals, but they have to have the capability to do it. We have to find a pathway. We have to get from where we are today to where we want to get to. And that's going to, in my opinion, take a lot of collaboration on the part of the policymakers, the utilities, obviously, the other players, and research and developing new technologies can play a real important part. There's going to be new technologies that we've never even thought of today. But I think people have to sit down, roll their sleeves up and say, okay, how are we going to get from where we are today to where we want to get to? So I think that's the meat and potatoes to make this meal possible.
Yeah, Dr. Reed.
Yeah, so I don't have anything more to add, but maybe I just, based upon what I would take away from some of this discussion that we just had is actually that there's a real need in order to effectively get there through partnerships, right? So whether that's partnering across the whole ecosystem, right, from communities, which we started this discussion, right, almost an hour ago about, but through research universities, through interactions with the private sector, as well as then, of course, doing our best to educate the policymakers when change is needed. And a way to do that is around frequent convening, right? So that you shouldn't only convene and get together and have a discussion when there's a challenge, but when It's just a help update of where things are. And so I think constant kind of dialogue is critical to the success, especially if we're trying to accelerate this process. And one aspect that I think that also comes up, just to mention, is that this, again, as a scientist, we don't do this always well, but documenting what went wrong or what didn't work, right? So one way to help us accelerate is so that we document what we learn here, so that other parts of the world or country, when they're going through the same process, that they don't go off and try to reinvent the wheel if we already know that that wheel didn't work very well. And I think that we don't do a lot of that because it's not the most exciting thing. It doesn't work into science papers. It doesn't make it into press releases. But it does actually it is a huge service to the broader global community. And I wonder if there's ways we can think about how to do that in an innovative way that can be really useful.
Thank you. So I'm seeing the time, and I think we have time for just one more question. I know everybody is time constrained. So the question that I'm going to ask you is, how can we foster collaboration and cooperation among the different stakeholders and sectors to address the climate crisis? And, tell us about the New York Climate Exchange. And I'm going to start with Bob.
Well, I think I'm just going to build on what I said earlier. I think how we can foster this is by getting people to talk more to each other, get people together. I think we could, have some, whether you want to call it webinars. I'm more of an in-person guy than a webinar or a Zoom guy. I like to see people in the room and interact. And, so I think that's one way to do it, is to just get people together more, discussing the issues. We talked about a lot of the problems, but there are a lot of opportunities for solutions. You mentioned the climate exchange, which is a large undertaking being led by Stony Brook University. Kevin might be able to talk a little bit more about that tonight, but there's an opportunity there as part of the climate exchange that we're calling it, to get people together, to have forums, have discussions, and really focus on the solutions. And how do we get together to achieve these solutions?
Yeah, let me just jump in on that, because first just mention what the New York Climate Exchange is really quick. And so, as mentioned, really far back at the beginning of the call, the New York Climate Exchange is a brand new nonprofit that was just started in New York and New York City about at the end of April of this year of 2023. And what makes the New York Climate Exchange really unique, I think, in this space is that it is not just a partnership of multiple academic institutions that are led by Stony Brook, but it's also a partnership of industry and some world-focused program companies. And then it's really a partnership of 30-plus community groups that are based in New York City. And the idea here is that it's really meant to be an exchange. That's what the name really means. It's an exchange of ideas, it's an exchange of knowledge, and it's an exchange, hopefully, of solutions in the long run. And it's an exchange of opportunities. And a big part of that is bringing people together, right, in the physical space to do that type of exchange. And so the idea is that the New York Climate Exchange is building. It'll take a few years. We're going to build a brand new facility right on Governor's Island, which is just a 5-minute ferry ride from Wall Street in Manhattan. And it is going to be a place to have all of these type of discussions, both the challenges, but also the opportunities. There'll be a conferencing facility in order to have workshops of anywhere from, a couple 10 experts, maybe 10 experts to a couple hundred. There'll be students that'll be coming there for a semester to learn about climate change or sustainability or clean energy, and they'll come from their home institution and then they'll go back. So it'll be a way to just have them learn really quickly over a semester through lived experience of actually contributing to the sustainability of the island itself, maybe having to live a little bit differently than they would at in their home dorm, and then take that information and exchange it back to their campus. And it'll be a place in which we develop new ideas. We have research labs that can take advantage of the unique atmosphere of New York City and access to the harbor, but also a way to incubate all the way from developing the space for rapid prototyping to connecting to the ecosystem of capital funding, all the way up through actually helping to scale and commercialize solutions. And so, that I think that is a very ambitious, right? And that's what makes me the most excited about it, both about the New York Climate Exchange and being part of Stony Brook University, which is really helping to shepherd this effort. But it's really to be the go-to space for these discussions, but also to show that when you actually give voice to all of the stakeholders, including those stakeholders that are underrepresented, that don't typically have a seat at the table, that you can not only develop solutions rapidly, but you can develop solutions that the users, right, will already be ready to use because they helped right through that whole process, and you actually have better as an institution have understood what their challenges are when it comes to climate change. And so that was the quick minute, the quick 3-minute overview. But I think that it's really through providing a physical space that I think is going to have to enable this to really, really work.
Thank you. And Digaunto?
I would just end with I think Bob and Dr. Reed really put together how we should be thinking about it. But we also need very strong leadership. We have, at the end of the day, let's be very candid, a very fragmented sector, right? You have generation owners, you have battery storage developers, you have DER developers, you have transmission owners, you have transmission developers, you have distribution utilities, you have state regulators, you have private competitive developers of clean air technology. Providing space is very important, very good, but I go back to my MISO MVP days, MISO multi-value project days. It was at the end of the day, the regulators, the commissioners of different states working directly with national labs and MISO leadership. You have to have leadership to corral the different interests because time is of the essence. At the end of the day, right, we have to remember there is a massive sense of urgency. Electrification is happening as we speak. We're going to see 40% increase in electric demand by 2035, 70% by 2040, 150% increase in demand by 2050. The need for infrastructure is imminent, and the need for clean energy technologies to integrate with the grid is imminent. So leadership, I would say, should not be underestimated in the need for that leadership to driving these positive outcomes.
So, gentlemen, thank you so much. Let me thank you for your expertise and your perspective. And IEEE USA and its parent organization, IEEE, this is an area of focus. And we believe that, as you say, providing forums for technical policy exchange is critical. Bringing people together to address the problem is critical. And as an organization, the largest engineering organization in the world, this is something that we take extremely serious. We will publish this webinar US-wide, and given the fact that if you go into the IEEE USA, and anyone can come to IEEE USA website, we can share this worldwide. So I thank you so much for your time, your effort, your expertise. This has been an exceptional webinar. Thank you so much. And with that, we say goodbye. Thank you.
Very well. Thank you.
Bye-bye.